This video is a recording of the Practice Math Problems version 1.0. We're going to solve each problem one at a time, starting with identifying what kind of problem it is after we read the problem itself. So number one says ordered IV 1,000 milliliters of D5W to infuse at 125 milliliters per hour on admission. The drop factor is 20 drops per milliliter. How many drops per minute will we set the infusion pump? Well, this one's pretty obvious, but it is drop factor problem. So then we need our drop factor formula, which is volume to be infused times drop factor over number of minutes. Then we're going to plug in all of our information. So our volume to be infused is 1,000 milliliters. Our drop factor is 20 drops per milliliter. And the number of minutes, well, this problem doesn't give us the number of minutes, does it? But that's okay. We have a volume to be infused and a rate, and if we use these two things, we can figure out the time. So if we do 1,000 milliliters, which is the volume to be infused, divided by 125 milliliters per hour, 1,000 divided by 125, did I do something wrong? 1,000 divided by 125 equals 8. 8 what? 8 hours. Okay, then we can take 8 hours times 60 minutes, because there's 60 minutes in an hour, or 480 minutes. And then we just plug all this in. So we're going to do 1,000 times 20 divided by 480, and we get 41.67. But because it's drops, we have to round it to a whole number. So this would be 42 drops per minute. Remember, has to say drops per minute, not drops per hour, not drops per milliliter, but drops per minute is the correct answer. Okay, problem number 2 says, order Novolin R insulin 15 units per hour IV for a patient having surgery. Available is 250 milliliters of sodium chloride, 0.9%, with 100 units of Humulin R insulin. At what rate should the infusion device be set? And so this problem is ratio and proportion. So we're going to set it up with what we know, which is there is 250 milliliters of sodium chloride with 100 units. And what is ordered is 15 units per hour. So we're solving for milliliters per hour. And then you know the drill here. We're going to cross multiply and divide. So we're going to do 15 times 250 divided by 100. And we get 37.5, also known as 37.5 milliliters per hour. Good. Number 3 says, ordered Suprax 120 milligrams once a day for a child who weighs 33 pounds. The recommended dosage for a child under 50 kilograms is 8 to 10 milligrams per kilogram per day. Is the dose ordered the recommended dosage? Why? So first of all, this is a safe dose problem. And the first thing we have to do is convert this into kilograms. So you can just take 33 divided by 2.2, and you get 15 kilograms. And then we're going to plug in our weight here for the recommended dose, which is 8 milligram times 15 kilogram, and we'll see what that is, and then 10 milligrams times 15 kilograms, and we'll see what that is to get our safe dose range. So 8 times 15, is that right? Seems like a high number. 8 times 15, 120, and 10 times 15, 150. And this is milligrams per day. Milligrams per day. So the safe dose range is 120 to 150 milligrams per day. What is ordered is 120 milligrams once a day. Is that safe? Yes. The dose ordered is within the safe dose range. Okay, good. Okay, number 4. Ordered Novolin R insulin 15 units per hour IV for a patient having surgery. Available is 250 milliliters of sodium chloride, 0.9%, with 100 units of Humulin R. How many hours will it take to infuse 250 milliliters? So we're going to do this by setting it up like a ratio and proportion to get milliliters per hour, and then we can figure out how many hours it's going to take. So let's start with this. So what we know is 250 milliliters is in 100 units. And what is ordered is for it to run at 15 units per hour. So this will give us milliliters per hour. Cross multiply and divide. So we're going to do 15 times 250 divided by 100. And we get 37.5 milliliters per hour. FYI, this is the same as this problem, only this question is asking how many hours is it going to take to infuse? Well, if we know it's running at 37.5 milliliters per hour, now all we have to do is divide this by 250. So 250, which is our volume to be infused, divided by 37.5, which is how fast it's running, gives us 6.67 hours. Good. All right, let's take a look at our next page. Okay, next we have Lasix is ordered. Oh, this is a little bit different of a problem. I guess I redid this. Okay, Lasix IV safe dose range is 0.5 to 1 milligram per kilogram per dose. Patient's weight is 110 pounds. The ordered dose for the patient is 50 milligrams twice a day. Is the dose ordered within the safe dose range? Why or why not? All right, so this is obviously safe dose range. And we have to convert the weight from pounds into kilograms. So we're going to do 110 divided by 2.2. And we get 50 kilograms as our weight. Then we're going to take the low end, which is 0.5 milligrams times 50 kilograms. And 1 milligram times 50 kilograms. And see what we get. 0.5 times 50 is 25 milligrams per dose. You see that? Per dose. And then obviously 1 times 50 is 50 milligrams per dose. And that is our safe dose range. Now, what is ordered is for the patient to receive 50 twice a day. Well, if the recommended dose is 25 to 50, that looks good, right? 50 would be on the high end, but it says maximum dose is 200 milligrams per day. Well, if the patient's getting 50 milligrams twice a day, that's 100 milligrams per day. So is it within the safe dose range? Yes. And the reason is that 50 milligram per dose is within the safe dose range. And this was kind of like a double check, looking at it per day. All right, good. Number 6, ordered is 2,000 milliliters of D5 lactated ringer solution to be infused in 24 hours for hydration. The drop factor is 15 drops per milliliter. How many drops per minute will be infused via the gravity infusion pump? So this one, well, this one's easy. We got this. So this is obviously a drip factor or drop factor problem. I don't know what my writing's doing there. Equation is volume to be infused times drop factor over number of minutes. And our volume to be infused is 2,000 milliliters. Our drop factor is 15 drops per milliliter. And our number of minutes is 24 hours. 24 times 60, because there's 60 minutes in an hour, and we get 1,440 minutes. Okay, now we do 2,000 times 15 divided by 1,440. We get 20.83, but because this is a drop factor, we have to round to a whole number, so we'll have 21 drops per minute. Good. Number 7, heparin, sodium, 1,000 units per hour IV. The pharmacy has sent 1,000 milliliters of 0.9% sodium chloride with 20,000 units of heparin sodium chloride or sodium for a patient with a DVT. What rate should the infusion pump or infusion device be set? And so this is a ratio and proportion. And what we know is that there is 1,000 milliliters and 20,000 units. And what is ordered is 1,000 units per hour. We're solving for milliliters per hour. We're going to cross multiply 1,000 times 1,000 divided by 20,000. And we get 50, and that is 50 milliliters per hour. Okay, last one on this page is ordered 50 milliliter piggyback to be infused for 30 minutes. The drop factor is 20 drops per milliliter. What is the gravity rate? So this is drop factor. These are always usually pretty easy to point out. Volume to be infused times drop factor over number of minutes. Volume to be infused is 50 milliliters. Drop factor is 20 drops per milliliter. And number of minutes is 30 minutes. So we're going to do 50 times 20 divided by 30, and we get 33.33. We can't leave it like that. It's got to be a whole number. So it's going to be 33 drops per minute. Okay, great. Oopsies. Get my here again. Okay, I think we're back in business. Okay, number 9. We have ordered is 1,000 milliliters of lactated Ringer solution at 75 milliliters per hour. The drop factor is 15 drops per milliliter. How many drops per minute will be administered? So this is drop factor. And volume to be infused times drop factor over number of minutes. Volume to be infused is 1,000 milliliters. Drop factor is 15 drops per milliliter. Number of minutes we don't have, but if we do 1,000 milliliters divided by 75 milliliters per hour, we'll get hours. 1,000 divided by 75, that gives us 13.3 hours times 60 gives us, well, we'll just round it up to 800 minutes. Let's see what we get. 1,000 times 15 divided by 800, 18.75, and then we have to round that to a whole number, so it'd be 19 drops per minute. Okay, good. Number 10, ordered is 1,500 milliliters of half normal saline for 24 hours. The drop factor is 10 drops per milliliter. And how many drops per minute will you set the rate? This is drop factor. We had a lot of these problems. Okay. Volume to be infused is 1,500 milliliters. Drop factor is 10 drops per milliliter. Time is going to be 24 hours times 60 is 1,440 minutes. And let's see what we get. 1,500 times 10 divided by 1,440, 10.42. Can't keep it that way, got to round to a whole number, so we have 11, or I'm sorry, we should round it down, 10 drops per minute. Good. Okay, number 11. Ordered is 1,500 milliliters of D5W to infuse in 4 hours. What rate should the device be set? And this finally is a pump formula. And that formula is volume to be infused times 60 over number of minutes. Volume to be infused is 1,500 milliliters times 60. Number of minutes is going to be 4 times 60, 240 minutes. 1,500 times 60 divided by 240, 375 milliliters per hour. Pretty fast. Because that's a large volume to get in just 4 hours. Okay, last one on this page. Ordered 1,000 milliliters of normal saline to infuse at 125 milliliters per hour. The IV was started at 0900. When will the infusion be completed? So this is a little different of a problem, but if we take the volume to be infused, divided by the rate, which we've done this in previous problems, that'll tell us how long before the bag runs out. So 1,000 divided by 125, and we get 8 hours. And then we can just count up from 9 a.m. Or you can take 0900 plus 0800, right? Because we have 8 hours, and you get 1700, aka 5 p.m. Which would be nice to know, like if you want to kind of have a heads up on when your bag is going to run dry, so you know when you need to get a new bag. That's one reason why you would do that math. Okay, number 13. Ordered is 500 milligrams of aminophylline and 250 milliliters of normal saline IV piggyback to infuse at 25 milliliters per hour. The IV started at 1300. When will the infusion be complete? So this is actually just like the last problem, but we don't actually really need this part of the information. So that's kind of cool. So we're just going to take the volume to be infused, which is 250 milliliters, divided by the rate, which is 25 milliliters per hour. Some of you might be able to do this in your head, but just to be safe, we'll do 250 divided by 25, and we get 10 hours. And so if it started at 1300, 10 hours from then would be 2300, aka 11 p.m. Cool. Then we have magnesium sulfate, 2 grams over 4 hours. Available is 500 milliliters of D5W with 2 grams of magnesium sulfate. What rate should the infusion device be set? And so this is a ratio and proportion problem, right? What we know is that there's 500 milliliters has 2 grams of magnesium. And what is ordered is 2 grams. Oh wait, this isn't a ratio and proportion problem, is it? Available is 500 milliliters and 2 grams. Magnesium is ordered 2 grams over 4 hours. No, we just need to do 500 because this would be obvious, right? If it's ordered at 2 grams, we just have to take 500 milliliters divided by 4 hours. Oh, I think I know what this problem's asking us. 500 milliliters divided by 4 hours. That gives us a rate of 125 milliliters per hour. Right? Yep. I made that a lot more complicated than it needed to be. Let me erase this so I don't confuse anybody. Because I don't want to make a whole new video. Okay, let's look at this. Ordered is 2 grams of magnesium sulfate to infuse over 4 hours. Available, meaning what we're holding in our hand, is a 500 ml bag with 2 grams. At what rate should we set the infusion pump? So this is really a pump formula, right? Volume to be infused times 60 over number of minutes. Our volume to be infused is 500 times 60. Our number of minutes is 4 times 60, 240 minutes. Let's do 500 times 60 divided by 240, and we get 125 milliliters per hour. Sorry if I confused anyone. I think I started to confuse myself. You guys have probably heard me say this in class, but that's why I say don't do too much math because you start to confuse yourself. It gets kind of weird if you do it for too long. But I'm going to finish this out so you guys have this video to practice. Okay, ordered is Amicar 5 grams and 250 mLs for 2 hours. At what rate should the infusion device be set? This is also pump formula. I caught it this time. All right, so we have volume to be infused times 60 over number of minutes. Volume to be infused is 250 times 60. Number of minutes is, you can probably do this in your head, but 2 times 60 is 120 minutes. Plug all this in and see what we get. 250 times 60 divided by 120. We get 125 milliliters per hour. Okay, last one on this page. Ordered is 1,500 milliliters of normal saline to infuse for 12 hours. The drop factor is 15 drops per milliliter. What rate should the infusion pump be set? So this is obviously a pump formula. And our volume to be infused times drop factor over a number of minutes. So we have 1,500 milliliters times 15 drops per milliliter over 12 hours. We'll do 12 times 60 to give us 720 minutes. Plug all this in. 1,500 times 15 divided by 720, 31.25. We can't keep it that way. You got to round to whole numbers. We have 31 drops per minute. All right. Last page. I hope you're ready because I'm ready. Okay. Ordered, number 17. D5W, 250 milliliters to infuse over the next 2 hours by an infusion device. What rate should we set the pump? This is a pump formula problem. And our formula is volume to be infused times 60 over number of minutes. Volume to be infused is 250 milliliters times 60, and our time is 2 hours, so we're going to do 2 times 60, which is 120 minutes. And plug all this in. 250 times 60 divided by 120, 125 milliliters per hour. We love this rate. All right, next one, amoxicillin, 500 milligrams and 50 milliliters of D5 normal saline in 30 minutes by infusion device. That's what's ordered. At what rate should the device be set? This is a pump formula. So they gave us, whoops, making sure you can see me, formula. They gave us the dose of the medication, which sometimes makes you think it's ratio and proportion, but this is really asking us the rate. How fast should it run based on the time? See how it deals with time? That's how we know it's a pump formula. So volume to be infused times 60 over number of minutes. Our volume to be infused is 50 milliliters times 60. Our time is 30 minutes. Plug all this in. 50 times 60 divided by 30. 100 milliliters per hour. All right, number 16, Keflex 125 milligrams PO every 6 hours for a child who weighs 44 pounds. The recommended pediatric dose for Keflex is 25 to 50 milligrams per kilogram per day. Is the dose ordered within the safe dose range? Why or why not? So first we have to convert this into kilograms, and you can just take 44 divided by 2.2, and we get 20 kilograms. And then we're going to take the highs and lows here. So 25 milligrams times 20 kilograms. We'll see what we get. And then 50 milligrams times 20 kilograms and see what we get. 25 times 20 is 500. And that's going to be milligrams per day. And then 50 times 20 is 1,000 milligrams per day is our safe dose range. What is ordered is 125 milligrams PO every 6 hours for a child who weighs 44 pounds. So if they're getting 125 milligrams every 6 hours, aka 4 times a day, if we do 125 times 4, we get 500 milligrams. So is that safe? Yes, it's on the low end, but it is within the safe dose range. So yes, 500 milligram per day is ordered and within the safe dose range. All right, last one. Ordered is 2,000 milliliters of D5 lactated ringer solution to be infused in 12 hours for hydration. The drop factor is 15 drops per milliliter. What should the gravity infusion be set? So this is drop factor. And our formula is volume to be infused times drop factor over number of minutes. And we have 2,000 milliliters times 15 drops per milliliter. And our time is 12 hours times 60, 720 minutes. And plug all this in and see what we get. 2,000 times 15 divided by 720, and we get 41.67. And we can't leave it like that. Have to round to whole numbers. We have 42 drops per minute. There you go. Good job, guys. I also will have the paper copies with the answers that I've written here on Blackboard as well for you to review. So whether you're a visual or auditory learner, you'll have both of these as a reference. All right, good job, guys.